All right, so in 3.5, we dove a little bit deeper into slope. We talked about finding the equations of lines from a graph or from information given about that graph, and vice versa, graphing lines from different kinds of information. So number 1 here says, write an equation of the line that has slope 3/4 and y-intercept -1. So what formula is the easiest one to plug that into? The slope-intercept, right? Which is, what's the slope-intercept equation? Y equals mx plus b. So this is my m, this is my b, and I'd get y equals 3/4 x minus 1. So you don't want to leave it as plus a -1 because that can be simplified. Questions on that one? Okay, number 2 says write the equation of the line that passes through the point 4, -2, and has slope 3. So what's the easiest way to do it if you were given the point and slope? Point slope format, which is y minus y1 m times x minus x1. Okay, so again, you can kind of use these interchangeably, okay, depending on what information is given. But if they give you a point and slope, obviously it's going to be easier to use that one. If they give you the slope and the y-intercept, it's obviously going to be easier to use the first one. So this would be my x1, this would be my y1, and this is my m. I'd get y minus a -2 becomes plus 2 equals 3x minus 4. Distribute the 3 and then subtract the 2. Questions on that one? Okay, 3 says write the equation of the line that passes through point 7, and is parallel to the line with the equation of x equals 4. So if it's parallel, then what's true about the two lines? Same slope, okay? So I would use this equation to get the slope, and in this case, an x equals 4 is what kind of a line? It's a vertical line. What's true about slope if it's undefined? What's true about slope if it's vertical? Undefined, okay? So can you plug in undefined into an equation? No. What's that tell you about the other line? If this one has to be vertical through 4, so that it would be x equals 4, then this one's going to be vertical through what? 7. Good. So it's going to be x equals 7. Okay. If it was a y equals, then what would you do? If that said y equals 4 instead of x equals 4, what would my equation be? Y equals 1. Good. You would use the y. Does that make sense? Yeah? Okay. Number 4 says write an equation of the line that passes through the point 7, 1, and is perpendicular to the line with the equation 6x minus 3y equals 8. Okay, so now if it's perpendicular, what's true about these slopes? Opposite reciprocal. Same, okay, but it gives you a point again, so I'm still going to plug it in a point slope, but this time I want to use 6x minus 3y equals 8 to get the slope. What's one way to do it? How do you find that slope? I can rearrange it so that it's equal to y, right? So isolate the y. I would get -3y equals -6x plus 8. Y would equal -6 divided by -3, -8 divided by -3, so 3x plus 8/3, but the 8/3 doesn't even matter. All right, so the only thing I need from that, oh, sorry, Liz. It would be, yeah, because 6 divided by 3 is 2 and not 3. Let's try that again. 2x plus 8/3. Okay, so then from here, the slope would be 2, which means that the slope of a line that's perpendicular to it would be what? -1/2. Okay, there's also a shortcut for determining slope if it's in standard form. If this confuses you, stick with what you were doing, okay? But if you have an equation that's in standard form, so if it's ax plus by equals c, they're both on the same side, the x has to be positive, okay, all whole numbers, which is this case, this is 6x minus 3y equals 8, okay? Then the shortcut for the slope is -a/b. So if I did that, -6 would go over b, which is -3, and I'd get +2. So there's a shortcut if it's in standard, okay? But if you don't remember it, then you can always just rearrange it and isolate the y. All right, so now I've got the slope, and I've got a point here. So I'd get y minus y1, which is 1, equals -1/2 x minus x1, which is 7. Distribute the -1/2. and then add the 1. And I've got to add the fraction, okay? So 1 would be the same thing as 2 over 2, and I'd get y equals negative 1/2 x plus 9/2. You can leave it like that, or you can put it as 4 1/2. It's totally up to you. If you're just giving me the equation, it really doesn't matter. If I'm going to go graph that, then I have to convert it into 4 1/2, okay? Because you can't graph 9 over 2. Questions so far? Okay, and then the last one says, Tony's puppy weighed 10 pounds when it was 2 months old. It gained 2 pounds a month for 6 months. Write an equation for the puppy's weight, W, after m months during this time. So you could, there's a lot of different ways you could do this, but if you want the visual, okay, you could say that this puppy started at 10 at month 0, right, which would be, or sorry, month 2. Go back. So at month 2, it was 10 pounds, okay? And then he gained 2 pounds a month for the next 6 months. So then he went to 3, 4, 5, 6, 7, 8, gaining 2 pounds each time. So then he went to 12, 14, 16, 18, 20, 22. Okay, whoops, daisy. So that's one way to kind of visualize it. But if you think about it, every 1 month, what's happening to his weight? Going up 2. So if we're putting weight over months, then for each 1 month, the weight's going up 2, right? So my change is 2 over 1 every time. What could that represent in an equation? The slope. Okay. So if you wanted to say, right, the equation after m months, then I would say that y, which in this case is my w, equals 2m plus, where did he start at? So if we started at 2 months, he starts at 10, right? Does that make sense? Questions on any of that? Okay, go ahead and flip to your homework. Okay, so the direction said, I only gave you 53. It said 53 to 55, solve it algebraically. So algebraically means systems of equation. Okay, this is set up as substitution, meaning one equation is already solved for a variable. So if the top is telling you that y equals 4x plus 9, then what you can do is take that and plug it in the place of y. So I get 4x minus y, which is now 4x plus 9, equals 1, and then distribute the negative. And these cancel, and I get negative 9 equals 1. So what kind of an answer is that? No solution. Okay, if they did not cancel, and let's say I got, like, let's do 54. So everybody try it, because you didn't have to do 54 last night for homework. Okay, but I want you to try to solve the systems of equation. So solve one of those equations for one of the variables, or use elimination, whichever method you remember, and plug it back into the other one. So if I took and solved, and it doesn't matter which one you do, but I took the bottom one and solved for y, and I got y equals 2x minus 18, and then I took that and plugged it into the top one in place of the y. And I ended up getting x equals 7. Once you get that one, you can plug that x into either of the original equations. I plugged it back into the second one, and then I got, plug that y back in, and then I got that, no, I took the x. And then I plugged that back in, and I got that y as negative 4. So what should have happened if I had graphed these two lines? They should have intersected at 7, negative 4, right? What should have happened if I graphed those first, that number 53? They won't intersect. So if there's no solution, it's because the lines are parallel, they'd never intersect. Does that make sense? Okay. So I don't want to spend too much time on it because we don't have a ton left, but just a quick refresher on systems of equations, because you'll probably see something like it next week. SAT. All right, chapter 3, section 6 is called Proving Theorems about Perpendicular Lines. So some of these we've kind of talked about, and some of them are going to be brand new to you, okay? but it's additional information that you can use to apply to perpendicular lines. So the first is called Theorem 3.8. The number is not important. That just means it's the 8th theorem mentioned in chapter 3, okay? What is important is what it says. So if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if I have a linear pair of angles, which means they form a line, right? And they are congruent, this should make sense, right? What's true about a linear pair? They add up to 180. And so if they're congruent, what's that mean? They have to both be 90. And if they're 90, then what's true? The lines are perpendicular, right? So all that stuff should make sense, okay? This is just in one step. This is one proof, or one theorem that says that. Theorem 3.9 says if two lines are perpendicular, then they intersect to form 4 right angles. Again, mostly stuff you already know, okay? It's just putting it into words. So if I gave you a diagram like the one that's there, what you can say is angle 1 equals angle 2, or angle 2 equals angle 3, or angle 3 equals angle 4. And the reason is this. If two lines are perpendicular, then they form 4 congruent right angles. Yep. Have. Is this stuff included in your test?
Yeah.
Yeah.
But I mean, can we write theorem 3.9?
No. I don't want a number. Remember, the number is totally unimportant. If you are trying to prove that angle 1 is congruent to angle 4, and it's not going to be that easy, but let's just say it said, given this diagram, show that angle 1 is congruent to angle 2. You now know 2 ways to do it. One is that first thing that we just talked about, but the second is that these are perpendicular lines, so given A is perpendicular to B, and then you can go straight to the answer, but you would write 2 perpendicular lines form 4 right angles, okay? This one, 310 says if two sides of two acute angles are perpendicular, then the angles are complementary. So again, this is something that you could have gotten to through a proof because you already know all the details that lead into it. But if you're given a diagram like this, where these two are drawn, you've got 2 angles here, and it says that this is perpendicular, okay? That's telling you that the exterior angles, or the exterior sides of those angles, are perpendicular. AB is perpendicular to BC. And if that's the case, that's a right angle. If it's a right angle, then what's true? It's equal to 90 degrees. And then does that mean it's complementary? And why? It's a definition of complementary, right? So it's basically one theorem that's putting that all together. So if the exterior sides are perpendicular, then the angles are complementary. Okay, 311 says if a transversal is perpendicular to one of 2 parallel lines, then it's perpendicular to the other, which we have talked about. But again, you didn't get given it in a theorem format. So if a transversal, like in this case J, is perpendicular to H, and H and K are parallel, then J is also perpendicular to K. .312 is the first one with a name. Lines perpendicular to a transversal theorem, which honestly is just as long as if you shorthand what it says. Okay? In a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. And again, when we went over the ways to prove lines parallel, I gave you this one. Okay? We just hadn't got to it in theorem form yet. So if M is perpendicular to P and N is perpendicular to P, then M and N are also parallel. Yep. No, so you can't use transitive in terms of perpendicular. But you could say, the long way around this is if M is perpendicular to P, then that angle is 90 degrees, right? If N is perpendicular to P, then that angle is 90 degrees. If those two are equal to 90 degrees, they equal each other, and then they're corresponding. So if the corresponding angles are congruent, then the lines are parallel. It's just we did it all in one step this way. So if you forget it, you can always work around them. But it helps you kind of shorthand things a little bit more. Alexis. This one you can use the name. Yeah. Did I give you a name for? Okay, distance. And this is the distance from a point to a line and the distance between two parallel lines. So from a point to a line, the shortest distance is the perpendicular segment that connects that point to that line. So if I asked you to find the distance from point A to line K, it doesn't mean you draw lines anywhere you want and you actually measure them. You want to find the perpendicular segment, and that's the shortest distance, right? Shortest distance between two things is the perpendicular line that connects them. Same thing with parallel lines. So between two parallel lines, the shortest segment is the perpendicular segment that joins the two parallel lines. So there could be multiple ways to measure it, but this is the same as this, is the same as this. You just have to show that they're perpendicular. That's the shortest distance between those two lines, which is true distance. All right, so example 1 says, in the figure, angle 1 and angle 2 are congruent. What can you conclude about the measure of angle 2? What could you tell me about angle 2? What's true about the relationship between 1 and 2? They're adjacent and they're a linear pair, which means what? 180, which means they would both be 90 degrees. So what could you tell me about the measure of angle 2? It's a right angle, or it equals 90 degrees. So they have to form a line, and they have to be congruent. If that's the case, then they're both 90. Okay, this one says, prove that if angle 1 and angle 2 are complementary, then BA is perpendicular to BC. So let's walk through it like it's a proof. So angle 1 is complementary to angle 2. What's that? Given. Now what? What's it mean if they're complementary? They equal they equal 90 degrees. And how do you know that? Definition of complementary. How would I know that something is perpendicular? What does perpendicular mean? They make a right angle, right? So I have to say that one big angle. I have to say that this is a right angle. How would I make that one big angle? ABC is what? I can't show it's 90 degrees yet, but what is ABC made up of? ABD and DBC, or let's make it numbers just so it's easier, right? Angle 1 plus angle 2, what's that called? When I say that an angle is equal to the sum of its parts. Angle addition postulate. So now if angle 1 plus angle 2 is 90, then angle ABC is 90. What's that called? Substitution. And if angle ABD is 90 degrees, what's true about those lines? If it equals 90, then they're perpendicular. All right, example 3 says determine which other lines, if any, must be perpendicular and explain your reasoning. So what's given to you is that C is perpendicular to B, right? Everybody sees that? Okay, is there another line that's perpendicular? A is perpendicular to C. How do you know that? How do you know they're parallel? What proves lines are parallel? 6 ways. Give me one. Corresponding angles are congruent. Do I have corresponding angles that are congruent? Yes. So if I'm going to do this in a proof, I would obviously state that given there's a perpendicular that they're both 75. But then I could say that A is parallel to B, and that's the corresponding angles postulate, which says if two angles are converse. If two corresponding angles are congruent, then the lines are parallel. And then I can say that A is perpendicular to C, because if one line is perpendicular to, or if a line, to one parallel line, then it is perpendicular to the other. So again, if I was to work that out in a proof, I would have to show that the first pair of lines are parallel, and then if they're parallel, it carries across to the other transversal, and you've got that if C is perpendicular to one of two parallel lines, that it would be perpendicular to the other one also. Okay, last one. This says, what is the distance between two parallel lines of this tabletop? So how do I show the distance between two parallel lines? What kind of segment would it be? A perpendicular segment, yes? Okay, so could I just eyeball what looks perpendicular? Could I just see, does it maybe look perpendicular? No? You can't? How could you show that something's perpendicular?
Oh, and then you say show it. Basically, you just look at it.
Could
See if a line's perpendicular.
No, but you can't.
You can tell if they're intersecting.
They have to be intersecting, but somebody said it. They're slopes. What has to be true about their slopes? They have to be opposite reciprocal. So it does look like my guess would be that either that segment or this segment, right, would be perpendicular. But in order to figure it out, I would want to find the slope of these lines. And then the slope of the line I'm going to assume is perpendicular, and they should be opposite reciprocal. I'll tell you now that that is the case. I'll work this out because the bell's about to ring. I'll work this on the video, but that is the case that far. But you do have to figure that out. And then if that's the case, how do I find the distance between 2 points? The distance formula. So you got to go back to that, okay? Which again is something that is great to review before PSAT.